All right, so this is a picture of one of the first generation computers. This was the Mark I, also known as the IBM Automatic Sequence Controlled Calculator. And basically all it was a general purpose digital calculator that was used by the US Navy towards the end of World War II. Okay, just to give you some idea of the size, this computer was 51 feet long, 8 feet high, and 8 feet deep. So it was massive. Grace Murray Hopper was born on December 9, 1906, and she died in January of 1992. She was an American computer scientist and a United States Navy Rear Admiral. In 1944, she was one of the first programmers of the Harvard Mark I computer and invented the first compiler for a computer programming language. She's one of my personal heroes. There's a big conference in computer science called the Grace Hopper Celebration of Women in Computing, and it's in honor of Grace Hopper. And, women in the field of computing get together and have this amazing big conference. It's one of the largest computer science conferences now in existence. While Grace was working on the Mark I, she was programming and noticed that they were having an issue. Okay, so they were constantly having to change out vacuum tubes, things like that, because they were always burning out. So maybe they'd be able to code a couple lines of code, and then they would have to stop, go look for the most recently burned out vacuum tube, and replace it and continue on. Okay, so one time she went to see what was happening, and it turned out that there was actually a moth that was messing around in the vacuum tubes. Of course, moths are drawn to the light, and that's what was causing the problem. So she took out the moth, actually taped it into her notebook. That's what you see here. And this sort of coined the term bug, as in a computer bug. Okay. I just wanted to show you there's a Google Doodle in her honor. Like, she's really an amazing woman. If you have time to read about her, you should. Okay, so continuing on with our first generation computers. The UNIVAC predicts the 1952 election. In 1952, the UNIVAC mainframe computer was used to predict the result of the U.S. presidential election. So after inventing the ENIAC, J. Presper Eckert and John Mauchly developed the UNIVAC for the Bureau of the Census. It was the first American computer designed for business and administrative use. When their company was sold, Remington Rand manufactured the machine. This was the fifth of its kind, and it was built for the U.S. Atomic Energy Commission. But it was first used in a promotional event by CBS to predict election results. Okay, so Grace Hopper worked with this team. She worked with Remington Rand and a team of programmers who input voting statistics from earlier elections, and then they wrote code to allow the calculator to predict the result based on previous races. So the UNIVAC was located in Philadelphia, where a statistician named Max Woodbury worked on algorithms and entered the data, and CBS's Charles Collingwood was reporting. It was connected to a teletype machine at the CBS studios in New York City, where Eckert was on hand to explain how it worked, and Walter Cronkite was on the air. So, this election was between Dwight Eisenhower against the governor of Illinois, Adlai Stevenson, and all the opinion polls were favoring Stevenson. So the UNIVAC's early prediction was made before polls were even closed on the West Coast, and its prediction was that Eisenhower would collect 438 electoral votes to Stevenson's 93, and that Eisenhower had 100-to-1 odds of winning. Everyone said, no, 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 that can't be correct. There, of course, is a mistake. This computer knows nothing. Do it again. So Woodbury reworked his algorithm, and guess who won the election? Eisenhower, right? The UNIVAC was correct. This was a great success. This was a great publicity event. And UNIVAC soon became a generic term for a computer. Okay. For the next election, that was in 1956, the networks again relied on computer analysis of the results, and obviously they still do today. If we look back at our own November election of last year, we see that sometimes the computers make mistakes. Okay, so let's talk about vacuum tubes. Okay, first generation computers use these vacuum tubes, and vacuum tubes resemble light bulbs, as you can see by the picture here. Okay, they put out a ton of heat, and they were very unreliable. They were big, they took up a lot of space, and you had to use actual manual switches in order to process any data. Okay. So something had to be done about that. So they came up with the second generation of computers, which used transistors. And as you can see here, the transistors were a lot smaller than the vacuum tubes, okay? And they were much more powerful, they were a lot more reliable, and they were able to be reprogrammed in a lot less time than it took with vacuum tubes. So this happened in around 1947. Okay. Third generation computers, they started using the amazing technology of the integrated circuit. Okay. Integrated circuits were developed in the 60s, and all they are these silicon chips that contain a large number of tiny transistors. These circuits enabled third generation computers to be faster, smaller, and more reliable than the previous two generations. Fourth generation computers introduced the microprocessor. This technology attributes its development to the success of the integrated circuit from the third generation. So if it hadn't been for the generations before, we wouldn't be where we're at today. Okay. The first microprocessor was developed in 1971, and this single chip was as powerful as the ENIAC of 1946. Okay, so pretty much as powerful as the computer that just 30 years prior had taken up an entire room, right? Microprocessors house the central processing unit, which is a CPU, also known as the brains of a computer. We'll get into that later, I promise. And microprocessors can have billions of transistors. Yes, billions. Okay? So just to review, first generation computers use vacuum tubes. Second generation used transistors. Third generation used integrated circuits. And then the fourth generations, which is where we currently are, use microprocessors. Okay, so here's a picture showing you the ENIAC on the left versus our current microprocessor on the right, which is pretty much the size of a quarter. We've come a long way, haven't we? So let's talk about something called Moore's Law. You may have heard about this in the news. If you read any sort of technology news, you'll definitely hear about this. Okay. In 1965, Intel co-founder Gordon Moore predicted that the number of transistors on a chip would double every 2 years. Okay. However, the current trend is closer to doubling every 18 months. So this continual increase in capabilities affects processing speeds and storage capacity. As technology improves, size and cost decrease, while speed, power, and reliability increase. The chip that's currently in your cell phone is more powerful than the first microprocessor that was developed in 1971. Okay. So again, Moore's law predicting that the number of transistors on an integrated circuit would double every 2 years. Okay. The current trend is closer to 18 months now. So that's why when you buy a new machine, a new computer, in a couple of years, it's almost outdated because of the current trend and how the technology is sort of doubling every year and a half. All right. So, computer data is digitally represented as binary code. Binary code is something called a base 2 system. This means it only has 2 states. The states are often represented by the digits 0 and 1. A single state, so a 0 or a 1, is called a bit, and it is the smallest unit of information. 8 bits equals 1 byte, and it is a byte that is used to represent a single keyboard character. All right, so say you hit the letter A, that's going to be represented inside of your computer by a byte of information. Okay, and we may go over some binary further in another lecture. Okay, so here's a little table you can study. It tells you a little bit more about binary code, how a byte has 256 different possible combinations. Okay, we look at these by powers of 2. So we go from 2 to the first all the way to 2 to the 8th. Okay, and that gives us all these different possibilities. Okay, ASCII, which is how we say this right here, ASCII, uses 7 bits and represents 128 characters. Okay, this came about in the 1960s, and it represented 128 characters. It included English upper and lowercase alphabet symbols, the numbers 0 through 9, punctuation, and just a few special characters. So special characters, we're talking about percentage sign, asterisks, the pound sign, things like that. Okay. Unicode came about later on, and this is the standard that's used on the internet today. This includes codes for most of the world's written languages, mathematical systems, and special characters. It has codes for more than 100,000 characters. So when we go to measure data, data is always measured in bits and bytes. Okay. Bits measure the data transfer rates, so stuff like your internet connection speeds. And bytes measure file size and storage capacity. So maybe your laptop has a 800 gigabyte hard drive for storage, or it might have a terabyte, might have less than that. Okay, so these tables here on the side, you can browse through those and they'll tell you the different binary prefixes, the decimal prefix, the symbols. Okay, so you've heard we have terabytes, petabytes, exabytes, zettabytes, and yottabytes, and how many, the decimal value, basically, of that decimal prefix. Okay, I'll see you on the next part of Chapter 1.